Okay, for those who are joining our live stream, this is another episode in our design of the symbolic neural net framework for the next version of Wolfram Language. Just a second here. And we are looking, I think, at dealing with persistent state in neural nets. And I think we had a design for doing this last time. Let's take a look at this. Can I just run this?
It should work, but I can't guarantee it on your build.
Okay, something happened. Okay, so net state object is the way of taking a net and also representing some state information about the net in addition to the actual net. Is that correct?
Yes, specifically the recurrent states.
I think this recycling icon is bizarre, but anyway, let's not worry about that for a second. Okay, so then what you're doing here is a nest. So what is this? So this is some kind of, okay. All right, so this is going to then predict what to do next from this hello. Is that correct?
Yes.
And it's going to produce some different thing. It's going to magnificently predict what hello should be followed by. It's not a very convincing prediction.
Right, because we haven't trained it on anything. But
right. And how does the training relate to this state object business?
You don't train it on the state object. You just train it on the direct net. There are different methods of doing that. So you can give it.
Can we try this for something more real? Can we try this for something?
Yeah, we could.
What could we try it for?
So, I mean, we could do something like Alice in Wonderland and.
No. I don't mean. I mean something which has been pre-trained so that we actually have a hope of being able to have something reasonable happen.
Oh, we don't have any pre-trained language models yet, unfortunately.
We don't have anything in here.
So Tim is busy working on a language model. There'll be one soon.
Okay. All right. Fair enough. Okay. So do we have documentation for this net state object thing?
No, we should create that. We hadn't got that far last time. We had to move on to the machine learning meeting, so we didn't have time to make a page for that.
Okay. All right. Let me see whether I can actually do that in this build. Start DocuTools and so on. So this works. Yep. Okay. So we don't have a net state object page. We just have.
Yeah.
Did we ever put the wrapper? What are we doing with the net evaluation function business?
We decided that we were going to use the function repository for that. So for now, we're just going to have a pure function in the model gallery,
in that model
repository. Yeah.
So did we document that in NetModel that there is such a thing?
We have not.
Okay. So in here, possible properties in NetModel include, presumably should include this, right?
Yes, once it's implemented.
What is it called?
I think we're just calling it evaluation function.
Okay, as opposed to evaluation net.
Exactly.
Are you sure that's the right thing? Because it's the meaning of evaluation is rather, well, no, you're right. That is the right thing to call it. Okay, well, let's add a line here for evaluation function. Is that coming in the next few days?
I think so, but it can also be added. Yes. So it just has to be added to the resource repository. That's the only thing, and that's asynchronously updated from normal release schedule.
But we should have it here. So. Okay, so what is this function? What's the what is the correct description?
Let's see.
Just tell me what it is. It's you. Is there a preprocessor and a postprocessor, or is this thing wrapped around the whole thing?
So it takes the network and it can do arbitrary operations on the input and the network. It could evaluate the network.
Specifically, if this evaluation function is f, what is actually computed?
So it computes f of then, I guess then the net is often in the pure function. So it takes in an input as the main input. So f of.
All right. Okay. So then this is. So then the function, the network is referred to by its net model designation inside the evaluation function, but that doesn't work because that's self-referential.
No, it's not. The evaluation net will be referred to inside the evaluation function.
Oh, I see. I see.
Yeah.
Okay. All right. Complete function to be used for evaluation. Right? So we should say when supplied, when present, evaluation function defines the complete, specifies the complete evaluation specifies the that's just exactly what we said right here. How should we say this? Well, the way to say it is that this trumps evaluation net, right? Present evaluation function.
It calls evaluation function.
You know what? Why don't we do this? Why don't we say the default, the effective default value for evaluation function is net model dot evaluation net. Correct?
I agree.
Okay, great. That's that. Okay, now let's go on to net state object. And there are no other functions there are no other new functions we have to bring in here.
I've on two minds about that. I think there's a case for, I think I mentioned this last time, there's a case for a function called something like net attach loss.
No, you didn't. What on earth is that?
Well, when you do training, you don't have to specify the loss function or how you're going to turn the net that you're training into a training network. Because normally you like add on these like auxiliary pieces that match the output of the net with a desired output using a loss function, right? And that's what that cute little diagram was. Remember, in the documentation for net trainers explaining how we do that. And so we give there's a rich language that you can use to do specific things when you create this training network from the original network. But there's no straightforward way to like see what that training network is. It's just something that NetTrain does, and it's like
I don't understand. To create, what do you mean creating the training network? So we've got an original network, and then what's the difference between the training network and it's a network with a bunch of weights, and the training function is going to adjust the weights.
The training network often turns the output of the ordinary network into an input. Okay, so
I'm not sure we've really gone through this. So what is this now?
Look at the middle picture.
Okay.
So that sub piece there, the cyan net, that's the training, that's the ordinary network. That's what you gave to NetTrain.
Yes.
And it constructs a bigger network by connecting the purple loss layer to the network, typically.
Wait a minute. Well, where's the loss layer coming from?
It's chosen based on the network automatically. So, for example,
I see. So the issue is if you want to give a different loss layer to NetTrain, how do you do that?
I mean, you can already. There's a grammar for how you do this. if you look up, it says when a loss layer is chosen automatically for a port, the loss layer to use is based on the layer within the net whose output is connected to the port as follows, blah, blah, blah.
Okay. But so
There's
what
a
happens if you want to specify your own loss layer or loss function, which could in general be an arbitrary loss function? It doesn't have to be a single layer. Isn't that true?
Yes, you can do that. And there's nothing stopping you from doing all of these things now. The difficulty is that you don't ever get to see the final training network that is constructed based on your specification. So I'm suggesting splitting off that functionality into a function, separate function that takes the same, it's the same argument that NetTrain takes, but it just shows you what the training network is. And if you want to, you can then do that as a separate step. And I think it's useful for pedagogic reasons to like see, to break out this step to show you what the magic is to like.
Okay, but so maybe that should be an option to NetTrain.
What that it doesn't do
a specific property of the training session. Why not just say, right? Because NetTrain, you're saying that's pre-processing that NetTrain is doing on the network to prepare it to be trained.
Correct.
Right. So let's look at what those properties can be. Let's see, where do we have that specified? Property can be any of the following.
Yeah.
The trained network, that's the output from this. Well, why don't we have a setting for, a value for property that gives you the to be trained network?
Yeah, okay, that's one way to do it. Sure, we could do that.
Seems sensible, right? Because that way I don't see the reason to introduce a whole nother, because this is part of the functionality of NetTrain. It's just short-circuiting it and not going through the whole.
Well, it's not actually training anything, so it is violating the one the verb in the name of the function. It's no longer doing any training.
Well, it is providing the training network, although it is not. We could potentially say training net. That is the network which will be trained.
So I've done it this way already. I'm trying to remember what the property I gave it is, but clearly I hadn't documented it yet. So let me find the property.
Let's find out. But I'm suggesting training network, perhaps, to represent the network to be trained.
I called it a loss net, but we could call it a training network.
Well, if it's the whole network, it should not be called a loss net.
Yeah. Sebastian, what do you think in terms of name?
I prefer training net. I agree with Stephen, like loss net is a bit strange.
Okay, cool. Do you want to add it?
Yeah, I'll add it to futurize it. Or are you?
There's actually a lot of properties that we added in the cycle that have just been collecting up, which we should review, and we might as well review it in this meeting. So I'll put them in an email while we talk about something else.
Okay, all right, okay. The network to be trained. Let's see, the network prepared for training.
I like that. And then you could add to that by attaching, I don't know.
Well,
loss layers. How about that?
Yes, we could do that. Okay. As prepared for training by appending loss layers, yes?
Yeah. I mean, sometimes we don't do that. It depends on the actual network, but in general, that's what happens. Yeah.
Let's make it as a separate note. Okay.
Remember, we already have that whole section of the notes that tells you how we constructed it. It's right above you. So we might want to mention it there.
Okay.
Yeah. We just say like the property training net can be used to retrieve this network, this network.
Well, let's read it through later. Okay. Let's come back to this when we go back to talk about other properties. Let's right now let's deal with net state object. Okay. So this is slightly tricky, right? Because this is supposed to represent a mutable, okay, net state object. So let's take a look at how we would say this. Represents an updatable represents a neural net with updatable state derived from net. Is that correct?
Yes.
Looks like we have a spelling word there. Do you think it's spelled correctly there, or do you think it's updateable like that? Maybe Sushma could ask GQA and they could tell us, and we could add this to the spelling dictionary when we know what the right answer is. Okay, let's take a look at this net. Let's take net chain as an example. Is that a reasonable description here?
I mean, there's some points that I'd want to fit into that sentence somehow. Like, for example, a state is stored inside the object. I don't know if that's obvious from the wording that you have.
With a stored updatable state.
Yeah.
Initiate, represent, initially, a neural net initially derived from net.
Can't you say it represents a version of net in which there is a stored state, a stored updatable state?
No, because that's not the right thing. Because this is, well, wait a minute. Which part of net ends up being updated here? That is, if we've got a net, a random network. So tell me the answer to that question. If I've got just a random network with, random linear layers and things like this, what if I feed that into a net state object? What can I apply to the net state object? And then I just start, so what happens is when we have net state object of net applied to data, right, that is going to actually cause an update to occur. Is that correct?
Yes, that's correct. But you see, I would in that thing you just wrote,
this should
dot instead of net. Because
creates a neural net. Creates a neural net derived from net, but with a stored updatable state. Is that more correct?
There's still one little niggle there, which is that the thing it creates is not really a net, in that it doesn't work with all the ordinary functions like net extract and whatever. You can take out the net from inside it, but it's just like, for now, it's an opaque object. It doesn't behave like a net except for evaluation. We can revisit that, but...
Okay, how do you get the net out from inside it?
You could just say creates an object. Good question. I propose normal.
Okay. That will get the current state of the net out. Is that correct?
No, because
yes.
Well, yes. As it stands now, the recurrent states aren't even stored in a net in the first place. So what you get out will always be what you put in, and all the recurrent states just evaporate. There's nowhere to put them in the net. They're completely ephemeral. So in future, if they're different kinds of state,
your audio is
besides recurrent state,
like the audio is beginning to break up. But keep going.
Sorry.
Well, yeah. Okay.
In
so
future,
you're saying what? Hello?
Can you hear me okay now?
Yep. So you're saying that net state object is storing additional information, but with additional stored updatable state information.
Yes.
Okay. Creates an object derived from the neural net, derived from net, that represents a neural net with additional stored updatable state information. that
Sure.
right?
Yes. One potential clarification is that the user can't directly update anything. So updatable suggests that the user can do that.
I see.
I mean, if
With additional
instead of
stored state
updating-
information that is updated when the net is evaluated, when the net is evaluated, is that right?
when the object is, yes, or when the object is applied.
When the net is applied to data.
Yeah, perfect.
Input, applied to input. To data to input.
I don't mind.
Okay. All right. So then what we have to say is, so let's see, the C alsos here will be to net chain and net graph, correct?
Yeah, and crucially, I think it should be a list of all the layers that
Exactly. Right.
do
To actually do this.
the
So this is
statement.
the various recurrent layers, right?
Yeah.
Okay, so let's look here. And I should need to remind myself what those actually are. So let's see, where are they? Recurrent layers. They're those three layers, right? Basic, recurrent, gated, recurrent, and LSTM. Is that
Yes.
correct?
There's also a net fold operator.
Okay, that was brilliant. Not very useful. Okay, I think it's faster just to type it. Net recurrent, basic recurrent layer. Gated recurrent layer. Long, short-term memory layer. Very boring to watch being typed. Okay, net fold operator, right?
Yes.
Okay. Someone is asking from our live stream, does net state object just do forward and backward pass with preserving RNN state? Is that right?
It represents recurrent states at the moment. I mean, other kinds of states that we want to task it with representing in the future. Like, for example, weights that can change.
Tally, your audio is.
Okay, I'll disconnect and read.
Thanks. Sebastian, while we're at it, let's okay.
Do you want to finish with that question, or I think Tally?
Well, did you know the answer to the end of that question?
Sure. So right now, it's the only state is represented as the recurrent state. In the future, we also want to represent states like doing backward and forward passes, and and you can update this object. You can get the gradient and then have your own little gradient update rule, and then update this object. So things
How
like
would you update the object?
That's a good question. We haven't thought about this that much yet.
Yeah.
Well,
so one of the things we want to do, one of the things we want to do is, the next few days is prototype what that would look like, and we can show this to you, of course. If it is deeply incompatible with this basic plan of this net state object we have now, then we will pull net state object for this version. But I really don't anticipate that that's going to happen.
Well, let's talk about it for a minute. How would you do a by hand? Okay, so what's happening here is there is an implicit update which comes by just running the data through the net state object, right?
Sure. Yep.
Okay, so now there is the question of an explicit, effectively net train operation being done on the net state object. Is that correct?
That's correct.
Not quite. So the way that the thing you often want to do. By the way, is my audio better? I disconnected.
Better, but not perfect. But go ahead.
Okay. I don't know if maybe Mac is doing a download in the background or something, but it's
okay.
Nothing that I'm doing. So often you want to train a single thing two different ways simultaneously, right? That's what makes it impossible to express with a net train. And in such a situation, you're going to want to take one state object and then make two different training objects, quote unquote, from it, okay, or on it, and then update those training objects, feed them data as you desire. Okay, that's like one way of framing this whole thing. So it's not necessarily that you call nettrain with a state object. It's more that you create training objects, multiple ones, and then you can step them through an update process individually, independent of the original net state object.
Oh, hold on a second. So if we take nettrain is a kind of just a big automated thing that does the training. What you're saying is nettrain contains subpieces that you may need to break out.
Yes.
So what are those subpieces?
We think that it'll be creating a training object, okay, from a state object. So there'll be something like training object, maybe, or create training object.
Yeah.
Let me try to solve that. Maybe Sebastian.
Okay, Sebastian.
Okay, cool. So just for context for this thing, so there's two sort of places where a formalism like nettrain, so where formalism like nettrain where it breaks down, and the two major cases are for reinforcement learning, and the other one is for GANs.
Mm-hmm.
For something
let's walk through what those workflows are.
Sure.
Okay.
So which one first?
Reinforcement learning.
Okay. So reinforcement learning, what you do is, the question is, how do you get a gradient estimate of anything? So you have a network that basically proposes a step. So it gets some information, like for example, an Atari game, it'll look at the screen and it'll say, you've got 5 controls. Here's a probability distribution across those 5 controls.
Mm-hmm.
So that's what the policy network can do for this. So the question is, how do you train the policy network? So the answer for that is that you take a policy network and you sample actions from it. So it makes a prediction of what to do. Then you run, you use that action, you feed that action into the environment. The environment feeds you back another state. The network sees that state again. The same process happens again and again.
Right. So how does that relate to the workflow that we already have for things like active classify?
Hi, I'm back.
Oh, you're back.
I'm just using a 4G hotspot for now. It's weird. I mean, I've got fiber. It shouldn't happen.
Okay. So how does what you're describing in that workflow relate to how active classification works?
So, so active classification, I'm going to remind myself of this.
So this is a thing where you're trying to learn a classifier, and you have to make a choice at each step. What example? You are generating your own examples by applying a function that potentially does something in the real world.
Yes.
Okay. So walk me through how this.
So what we're describing could be used to implement a deep learning backend for active classification, for example.
Okay.
So what we're describing is a fairly low level. It's like the building blocks that you could build many different. You could do it for reinforcement learning. You could do it for GANs.
All right, but let me walk through again what you're actually saying. So you say instead of a net train, where generally net train takes the net, a single net, and a collection of examples, right?
Yeah.
Okay. So what are you now saying?
So I'm saying.
So basically, instead of that, you have a net, and you have an environment object.
Yeah.
Like the Atari game, and then
which is otherwise known as a function that will generate. I mean, here we've got particular configurations, right? And otherwise, active classification here takes this function f, right? Using the function f to define classes for the example configurations. So that's the environment specification there, is that function f.
Okay.
If I'm not mistaken.
Let's check this, but it's plausible.
So there are two things we could talk about. We could talk about how to do reinforcement learning, right? How to do deep reinforcement learning as a custom function. Or we could just talk about how state objects can be used in all these different ways, including deep reinforcement learning.
Well, I just want to check that the reinforcement learning path is actually going to work. That was the only reason I'm bringing this up. Because, I mean, we're defining the state object thing. And what you're saying is, I understand how the state object thing is useful once we have things like a language model where the actual network is going to change as it's fed data. I get that. Now, you're claiming that this generalizes to a different case where the where you need to, nip and tuck the network.
Well, basically, you're writing your own training loop.
I understand. So what's in a training loop?
There's usually an outer loop, and then depending on the kind of task that you're doing, you might have one or more networks that interact in various ways to generate gradients that are then used to update the weights of those networks.
Right.
And the way that they generate,
So one of the things we don't have. So how do we derive the gradients from a network? Don't we have? We were going to have, but we don't have it yet as net derivative. Is that right?
Yeah.
Or is it net gradient?
We have net port derivative.
Net port gradient currently. Net port gradient is it's not a function like that. It's more of a property description that you can use with existing networks to ask to get concrete gradients for specific inputs. So like on this input, tell me the gradient of this input. So you say like net open bracket input, comma, net port gradient input. Lowercase n. Yeah.
What? Of input? Yeah. What are you saying?
Well, that's no quotes. That's the data itself, input as a variable, or data. Okay. And then instead of asking for an output, the second argument, is the property that you want.
Yeah, I understand. So you say net port gradient of some random port.
Yeah, or multiple ports.
Right. Okay. Fine. So that's the way of querying for a gradient. But my question is, given a particular network and particular data, what we need is the analog of, what would qualitatively be derivative of net at data, right? Derivative, actually what this really is, it's actually kind of an interesting thing because, right, if you actually look at, if I say f prime, d of f of xy, comma, x, comma 2, for example, right, I'll get that. What is that? That is the derivative, the second derivative with respect to, it's the second derivative in the first slot of this function f on x and y. So what we want, presumably, is the analog of that for a network where we're saying the net derivative, if I'm not mistaken, of essentially with respect to such and such a port. If I'm not mistaken.
For training, you don't really want that. This is not really this feature is not really useful for training because what you really want there is the derivative on the weights, the gradient on the weights, right?
Yeah,
precise
right.
Derivative of the loss with respect to the weights. So, and then you want to take that and then you want to use it to update the weights in a complicated way based on a certain optimization algorithm. So most people don't want to write their own optimizers. They don't want to do plus equals blah, 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 blah with the gradients directly. They just want to say, use an off-the-shelf optimizer like Adam to update this following net based on gradients that I've generated in some way.
Our live stream commentator here is saying basically you need a control from which network node to back propagate, similar to TensorFlow with several losses and optimizers that run separately. Do you understand that?
Yes, that's what the two-trainer thing that I was referring to earlier is.
Okay. Well, do we understand what this is going to look like roughly, or do we?
I mean, roughly, but we haven't. What we haven't done is prototype it, and until we prototype, it's very easy to have like a mental model. It's not actually accurate.
So my question for net state object is: there is one use case for net state object at this time. You imagine that net state object,
yes, would allow you to
like the weights, for example. So if you're doing this custom training loop, you definitely want, you want the weights to be a state of this object and then update the state.
How are you specifying that this information is, how are you specifying which information is updated? Because normally when you apply a net to data, it just applies itself to the data. How does this know that inside one of these recurrent layers that there is something that is going to be updated as opposed to just do it and, and move on?
So state ports are special. So they're ones that the input and the output port are named the same.
So we already have this net state port. Is that correct? What we have net.
It's net. It's a new usage of net port. Remember, you can pass them in and get them out by saying all comma states. That's what we designed like 2-3 weeks ago.
Yeah.
Okay. So we need to describe that here.
Yes, we need to describe
this relates to net ports that are specified how.
So what do we say?
By the way, we are going to run out of time here, so
one random thing, by the way, can you give some guidance for me to send to Jeremy about the icon for NetState object? Just because I need to get the rolling.
Yeah, right. Well, I mean, that thing is ridiculous.
I know, it's a placeholder. It's not.
Did you actually get that from a recycle bin?
It's a Unicode icon.
Oh,
yeah.
For recycling. Okay, great.
Yeah.
Okay, you can, and then you have to read off the regulations for the particular town you're in about what you recycle. Okay. Well, what really is this? This is a network. And by the way, if we're going to discuss this, why don't we get Billy to join us, because he's probably going to be the one actually making the icon.
I'll call him.
Okay. So this needs to go with let's see. Well, what are we really trying to represent here? This is something where the state that's fed in sticks inside the object. Whew. What do you guys think? I mean,
here's how I would do it. I would have a little box, and it's got an arrow passing through it horizontally. That represents the input and the output. And then it's got another arrow passing through it vertically, which represents and kind of loops back. Do you know what I mean?
Not really, but yeah, okay. Hold on, let me so you're proposing, well, let's see if let's see, let me use my really high tech okay. All right, so you're saying, what are you suggesting? You're suggesting a horizontal arrow like that going through, this is really weird, going through something that looks like a chain, and then some recycling arrow like that? That seems kind of goofy to me.
Well, I wouldn't do a chain, just do a square. So
okay.
It's got an input on the left, output on the right.
Okay.
And that's all net.
Okay, right? That's a net. Yes.
That's a net. What's different about this guy is that it's got a little loop coming from the bottom back up to the top or something like that.
How does it loop around for?
I don't know.
Well, what are you trying to represent here? You're trying to represent the fact that it has internal state that.
Yeah.
But now this notion with arrows is what we've used to represent individual layers, isn't that right? Not complete networks. I don't know. I don't really believe in something like this. That just seems completely goofy.
Okay.
But okay, let's continue with the rest of the discussion for a minute. I mean, in worst case, you know, since this is identified as a net state object, we don't absolutely need an icon there.
Right.
Okay, but I still want to understand what it is we're saying here. So the first thing to say is net state object of net generates, well, let's see, that creates an object. And then the other thing that we need here is something which has a ... if I'm not mistaken. That is, what does this look like after you create the net state object? Right here, what does that thing look like?
Internally?
Yeah.
It's the net, and then it's an association of the states.
Okay, but do we need to document that separately, because this is both a generator
I mean, 0 is a perfectly good initial state.
By the way, somebody's asking on the live stream, how about document, i.e. additional information on top of a net? Yes, we are very much on top of that. We have this whole elaborate neural net repository that has huge amounts of additional information associated with networks. So for example, this is a typical network with examples, and it has all kinds of, it has its construction notebook that shows how the network is put together, et cetera, et cetera, et cetera. So I think we're in good shape in terms of that, that aspect of things. Let's go back. Okay, sorry, what were you saying here? Your so hold on, net. So you're describing what happens. Okay, so this, is there a separate line we have to give? It creates an object derived from the network. Let's see. So I'm trying to understand how this creates an object, which is in fact also a net state object. Am I making sense? You guys there?
I'm not sure if Tally has disappeared.
Sorry, you guys cut out for a second. What was said?
I was saying this is a creator and a representer of the net state object.
Right. Yes, it is.
So I think we need another usage line here that says something like represents let's see, represents a neural net with additional stored state information. I mean, is that, it's a little bit confusing.
Well, we don't do this elsewhere, like net information. Do we?
No, but net information doesn't generate something. It does not both a generator and a representer.
It does. Look at it. Oh, sorry, not net information, classify information. Net information doesn't do this yet, but we were going to make it do it.
Well, what do you mean it does this? I'm not seeing it do that.
Generates a report giving information on the classify function. Oh, I suppose we don't say what that report is.
No.
Okay. I'm
not certain we should do this here. So let's futurize that for a second, but let's try and write the rest of it here. Okay. Net state object. Okay. Net state object of data updates stored state information in the net state object stored state information. Let's see, state information. What are we going to say? Can be stored in recurrent net layers, such as basic recurrent layer. Is that correct?
Yes.
And now, how do we say this in weights? How do we say this? How do we describe the net?
You shouldn't say stored in. You should say state information is associated with recurrent net layers such as basic recurrent layer.
Okay. I'm going to have to go in a moment here. So
okay.
I think you guys need to continue this.
Yeah.
But
in particular, by the way, there's a second usage that we need to. I'll tell you the use case. Sequence to sequence type models where it's like it eats English and spits out French. The way you do it is that first it eats the English and it produces a state, and then you use that as a seed, and then you generate to produce the French.
Okay, so what's the use case? I mean, what's the description here?
It's something like a second argument which you use to create those initial states. And it's basically going to be an association that's the same form as net ports all comma states returns. So
okay. So wait a minute. So that's not just net. That's something where that's a place where what you're giving, if I'm not mistaken, is a net state object of net comma state info.
I noticed you said you need to go, but Chris Parati is here with us as well.
Okay.
And it's basically the seed, and that seed is 0. Like if you don't provide that state, then the seed
right creates an object. Let's see. In which additional stored state information is initialized using state. Is that correct?
Yes.
Or we could call it seed. Okay, this is Chris. We are trying to, have you been following the NeuralNet iconography stuff, or are you not? Have you not been involved in this?
Following that a little bit, and I've been working on something somewhat related for another task.
Okay, fine. All right, we need another icon which represents one of these net state objects, which is a neural net in which, as you apply it to data, like a brain, so to speak, it kind of learns by doing, if you understand what I'm saying.
Mm-hmm.
So in other words, rather than being explicitly trained in a separate, now you're going to school type thing, it is, it is learning on the job, so to speak. So we need an icon for that.
Okay.
And the current icon is ridiculous. It's this recycling bin thing.
Yeah.
We don't want a brain. Like we just want something relatively abstract, I think.
Yes, we do not want a brain.
So we're looking for an icon that is communicating, adapting. It's communicating that it is learning on the fly.
Well, it's changing on the fly. So it could be for learning purposes, or it could just be that it's just remembering what it's done already and it's doing something different.
Okay.
Yeah.
How do you represent something that
a bit of a tough one, yeah.
I've got it. Can I quickly describe?
Yes.
Okay. Arrow going to box and then coming out again. Just the ordinary.
I'm now doing my artwork here. So what are you saying? You're saying an arrow.
Just what you had above, right? With that, instead of a recycle.
Yeah.
The arrow going into the box, and then draw faint ghost boxes behind that first box that are kind of offset diagonally. Yes, and that represents previous versions of the box.
I see.
Okay, so it's sort of a pseudo 3D thing where we sort of have a z-axis that's going back in time, but also this y to show input and output that's causing the change.
Yeah, exactly.
Well, and maybe one could have ghosted arrows going in there. The ghosted arrows, and then this is a solid arrow here.
Yeah. That's like how Time Machine visualizes things, going back in time, the Apple thing.
Okay, that seems reasonable to me. Now, what about the iconography of the box to represent the complete network? I thought we would have. I would think it would be better to have something that looks more networky, because I think those pure boxes are what we've used for individual layers, if I'm not mistaken.
Mm-hmm.
But you can always have something that looks networky inside here.
Yeah, so we'd have the box and pretty, as you're illustrating there.
Right, some
And
networky thing.
we wouldn't want arrows coming in and out because we are indicating that it is a fully developed network.
Yes, but these arrows here, well, I see what you're saying. Well, wait a minute. You're saying, why do we have the arrows coming in and out? Because we don't have arrows coming in and out on this one.
For the completed network, do we want the arrows coming in and out?
No, I don't think so.
Yeah, I would think not either.
Tally?
I see. So just the stack of things. Well, the one thing, and maybe it's too devoted to this current use case, but the reason it's changing is that you're feeding it new data, right? But maybe
Which it might not be.
Which it might not be. It might be changing because something else changed in what I'm describing with the training objects. So that seems reasonable to like drop the arrows.
Right, but on the other hand, that is suggesting that the thing that's here is a history, and it's not. It is merely the current state. But I suppose that if what you're representing, if you're ghosting back the historical stuff, then that might be here's how we got here. You get what I'm saying, Chris? I mean, this actual thing is just representing where you're at.
Yeah, I would have to do some playing with it, but I initially like the idea of keeping the ghosted out layers in the background because it shows that this has been trained and data has gone into it to train it.
Fair enough. All right, why don't you try it? See what you can come up with.
Let me take a screenshot of your screen real quick.
What's that?
I was going to take a quick screenshot of your icon right there, but I think I got it.
Go ahead. It's hardly a brilliant piece of artwork.
Got it.
Okay. Okay, I think we have to wrap right now. And we'll continue, I guess, in the next few days. And I will push this back into the repository.
Thanks.
And for those who happen to be on the live stream, we will actually be back with a completely different subject in about an hour and a half, talking about financial data feeds. So see you all later.
Thanks. Bye.
Bye.
Cool. Bye.
Bye.